This is Mr. Reed's Year 10 Maths homework number 21. It's due in on Friday, as usual. If you could please get on with it, come and see me if you're stuck, at lunchtime or break time. Right, if we have a look at question 1. So this question is a probability question, and it's asking you about a normal 6-sided fair dice. Some fairly simple probability questions just to kick off this homework. So what's the chance of it being even? What's the chance of it being either odd or even? We're assuming we're rolling this dice just once and looking at the top number. What's the chance of it not being a 5? What's the chance of it being prime? What's the probability of the top number on the dice when you've rolled it being a factor of 8? And then the last one, what's the probability of rolling a 7? Remember, when you write probabilities in GCSE maths, we want decimals, percentages or fractions, no ratio allowed. On to question 2. This is looking back at a topic that we did before the holidays. You've got a function here, you've got to draw its graph. Now you should be looking at the highest power of x and thinking, I know what shape that graph is. And so it is going to be that U-shaped graph, but where is it? Is it going down here like this? Is it over here? You can't tell until you fill in this table of values here. So take each x value one at a time, plug it in, find your y value that goes with it. And remember, we talked about using calculators to do this, so I will give a hint here. On a calculator, if you're going to work out -3 as your x value, you would, in brackets, -3 all squared plus 2 lots of -3. And those brackets are absolutely essential on that calculator. Without them, I'm afraid you'll run into a BidMaths mistake here where your calculator will give you -9. And of course this makes +9. Once you've got your values, fill in the table for each value of x and then plot them carefully on this grid and then join them up with a nice smooth pencil curve. Remember, we don't use a ruler for the actual curve itself, you just use a ruler for the axes. On to question 3. Solving simultaneously, you've got equation 1 and equation 2. Using an algebraic method, solve with full working out. Part B of this says, how could you use a graphical method to answer this question here? So rather than using just algebra, how could you draw a graph to solve that problem? That will require you to write a sentence or two, possibly draw a diagram. Moving on to question 4. Now this is important. This is something that we've talked about in class. Unfortunately, you're a year group that were taught to use a grid method for multiplying, and I've told you recently in class that actually to get full method marks you need to learn this column. Some call it long multiplication, some call it column multiplication. Whatever you want to call it, you need to learn how to do it. Now I have shown you in class how to do it, I've talked about it and I've set you the task to go away and learn it. You definitely want to be able to multiply whole numbers and decimals using this method. I've said if you're stuck, you could always Google it. You could Google long multiplication or column multiplication. There's plenty of videos out there that will teach you what to do. I want to see a method like this in your book. That's very important. Right, on to the next one. Question 5. Again, we're looking back at work we did before the holidays now. Adding in standard form. Then you've got a subtraction in standard form, and of course you can see you've got multiply and divide. Now I am going to give you a big hint here because otherwise it can go wrong, this topic. When you are adding and subtracting, you need to turn these into normal numbers first. Once you've turned them into normal numbers, do the calculation and then put your answer back into standard form at the end. Now that's for adding and subtracting. When multiplying and dividing, you don't need to do that. You can just use your technique where you multiply your numbers and then deal with your powers. In this case, you're going to divide your numbers and then deal with your powers. So you no need to convert into normal numbers for the multiply and divide section. Do remember on all 4 of these questions to check your answer is in standard form at the end. On to question 6. Metric conversions. It's nice and simple compared to some of the work we do as a class, but it's still important. Turning millimetres into centimetres, metres into centimetres, kilometres into metres. Very careful here. Turning centimetres square into square millimetres. Do not think the answer to this question is 70. It is not 70. I'm going to make a note of that. not 70. I know that there are 10 millimetres in a centimetre, but it does not work like that for square centimetres. The same is true for question E. Please don't think that because there's 100 centimetres in a metre that the answer to this question is 400. It's not. Right? I'm going to make that clear. It is not 400. No. I don't want to see that answer. It's definitely not that. Right, on to the final question. Last page. And this is a topic we are studying in class this week. We should be doing a lesson on this on Wednesday. So there's 10 pieces of fruit in a bowl, some sort of fruit bowl. 6 of the pieces of fruit are apples and the rest are oranges. So you've got 4 oranges. And you've got to read the question carefully. It says Amy takes out a piece of fruit and she eats it. That does mean that there's less fruit in the bowl. And then Martin takes a piece and he eats it. And you've got 2 questions to answer. First question, and it will involve drawing a probability tree, this. So you've got to draw your tree before you even start. What's the chance that both people eat the same type of fruit? And then part B, what's the chance that they both eat a different type of fruit? So in other words, Amy has an orange while Martin has an apple. But of course it could be the other way around as well. So you've got to think about that. Draw your tree. Think about which path to follow on that tree and you should be able to answer that question. That's it, as usual. Please come and see me if you're stuck. I don't want to see partially complete homework. I need you to do all of the questions.